Hey geometry team, it's Mrs. Serna and welcome to Unit 9, Day 2. We're going to be talking today about the perimeter and area of a couple different shapes, mainly triangles and quadrilaterals. Now to get us started, we're going to be focusing on perimeter for about 5 seconds. If I can find my mouse. There you are. And so just a reminder, perimeter of anything is just the distance around the outside. It's a length, so it's amount of meters, it's amount of centimeters, it's inches, it's miles. And to get that amount, all you're going to do is add all the sides. Now, everywhere I've looked about this comes from like 4th grade math. So I'm not going to do a bunch of example problems of this because I'm going to assume that you know how to add sides of shapes. But I just wanted to remind you that that's what perimeter is, so that now as we move forward, we're going to start talking about area. Area is a different thing. So the area of a perimeter of a polygon or something is not a length. Instead, it's a measure of the number of square units inside a shape. And so if you see any kind of shape, whether it's curvilinear or, rectangular or square, something with straight sides, it's always going to be just counting the number of squares inside. So if you look at this circle or let's pick something simpler, the triangle, I've got 1, 2, 3 squares plus these half squares, so it's really 3, 4 and a half squares in this triangle. And so you'd say the area is 4.5 square somethings, square inches, square centimeters, whatever unit of dimension it has here. If you don't have a unit, you can even just say square units. But the point is, area always needs to be in squares. For something curvy, here we're going to have 5, 1, 2, 3, 4, 5, almost full ones, and then these 4 that aren't even barely a little more than half, and so it takes a little more work to find the amount of area in these curved things, and that's why they almost always end up having some kind of disgusting decimal on them, is because we've got an incomplete amount of square inside a curvy shape. And so focusing on area, let's start with the most basic and simple things. And that's going to be your rectangles. Okay? And so your rectangles are going to have an area found by doing your length times your width. So L times W. And in this shape, for example, oh look, it's a rug. It's rectangular. It's going to have a length of 8 and a width of 5. And my units here are feet. And so I pull out my handy formula. I drop the length in for the length and 5 feet in for the width, and it's going to come out to be 40. But notice that when we did this, we multiplied feet times feet. And thinking back to what we learned for exponents, feet times feet make feet squared. And that fits totally in with what we talked about area, measuring the number of square units inside our particular shape. And so for this one, there were 40 square feet inside this. And so if you drew the squares, you'd be able to count them, but you're probably not going to because, you're going to trust the math. Area always needs to be in some kind of square unit. So just make sure you don't leave your numbers naked, and that if you're doing area, you make sure you're counting the squares, not just a linear length. Okay, and so now we're going to get to a square. Well, if you recall from our unit before, squares are just a special kind of rectangle. So their formula is length times width to find the area. But we happen to know that the length and the width are the same in a square. It's just going to be a side and a side. So we can substitute that in and say that the area is really just the side squared. And interestingly enough, it is a square. And if you square the sides, you make a square. It's almost like the words are connected or something. So for this example, I have 1, 2, 3, 4 for my length and for my width. And so I'm going to have 4 squared for my area, which is going to give me 16. And you'll notice that I didn't put whether these were inches or miles or feet. And so I have units squared as my dimensional units for this, so that I'm still not leaving it naked. I'm still acknowledging that it's an area that needs to have square units. And so you can always go ahead and add your units at the end if you're not given them, and just say, we don't know what the units are, but they exist. Okay. For a parallelogram now, you have the area of a parallelogram. It's just a rectangle that's been smushed off on a diagonal a little bit. We've taken it and squished it over. But if you were to cut off this triangle, you could take it and slide it and put it right here and fill it in. And basically what you have here is a rectangle in terms of area. So the formula ends up being exactly the same as for a rectangle. It's still base times height. But notice that the height of anything is always measured perpendicular to its base. We measure your height straight up and down, not at a slant over to the floor over there somewhere. And the same is going to be true for this guy. If I want to measure the height, I need to go perpendicular from the base up to the top. I can also extend along the base here and figure out the height hanging out over the edge. It doesn't matter as long as it's perpendicular to one of the bases. And so the base and the height multiplied are going to give you your area here for a parallelogram. Okay, so an example here that I've got this guy here. It's 7 centimeters along the slant, it's 8 centimeters along the bottom, and then 4 centimeters here as my height. And so in order to do my area for base times height, I need to figure out which of these is going to be my base and which of these is going to be my height. And since base and height need to be perpendicular, I'm going to choose the two that are perpendicular to each other and ignore this extra information that I don't need here. So my base is going to be 8 centimeters, my height is going to be 4 centimeters. You plug those in and your area is 32 centimeters squared. Okay. Come on, buddy. Wake up. There we go. So now we're going to get into triangles. Well, a triangle is just half of a parallelogram or a rectangle if you were to cut it along the diagonal. And so the formula for the area of a triangle is just going to be half of the base times the height. Another way to write that is base times height divided by 2. They're the same thing. It's just a different way of writing it. And again, remember, your base is going to be one of the sides. Your height needs to be a length perpendicular from that side up to a vertex. So it needs to be a perpendicular height to find the area of a triangle. So you get to something like this guy, and you want to find the area. You go, okay, I need the base and the height. Well, here's my base is 7, but I don't have a height here. I know that there's a perpendicular here that would be great to tell me the height, but I don't have that amount. And so what started out as seeming pretty easy, I sometimes am going to have to figure out the numbers I need. Okay, I know I need this height, but it's not here. But luckily for me, I know that height is perpendicular. And so I can use that and treat this as a right triangle and use my good old friend, the Pythagorean Theorem. And so I'm going to focus on this triangle here so I can find my height right there. Okay? And so I'm going to look at it and go, okay, in this right triangle here, I have a side that's 3. I don't know this side, and I have the hypotenuse as 5. So I'm going to plug that into my good old friend, the Pythagorean Theorem here, to find the piece I need. So I'm going to go, okay, I have 3 for one of the sides, one of the legs. I'm going to use h for height for that second leg that I don't know how tall it is, but I need it for the height of my triangle. And then I know that that hypotenuse is 5. And so algebra, 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 I end up finding that this height squared is 16. I square root both sides, and my height is now 4. So I can come over here and say, great, now I know the height of that triangle. I did all that work just so I could plug it into this simple formula, 1/2 base times height. And so my base was this 7, and then I figured out that the height is 4, and so I know that the area is 14 square units. And you notice I've written it differently this way. There's lots of ways to write square units. And one way is to literally just write it out in words. So 14 square units. You could have also done it the way I did previously, where you just do units squared. You could even abbreviate even further and do u squared. It doesn't matter as long as you're communicating something about your units so that everybody knows what's going on. Clarity and communication are key in mathematics. Okay, now we're getting into a trapezoid. Ta-da! Remember, a trapezoid has two parallel sides that are not the same length, okay? So here's one, here's the other. And they're both called bases. So I have a base 2 here and a base 1 up there. It doesn't matter which one you call base 2 or base 1. It doesn't matter, so just stay calm. But we have two bases here, and we have a height. And you almost kind of think, wow, this would almost be like a parallelogram if only those bases were the same, but they're not. But fortunately for us, we can say, well, I know one is extra big, one's a little small. If I average those bases, that gives me an average amount to use to multiply times my height. So to find the area of a trapezoid, I'm going to add my bases and divide by 2. That's averaging them. So I'll average my bases and then multiply by the height. And that will give me the area of this, because again, it comes down to if you were to cut off triangular pieces of this and rearrange it, it would turn out to have an average base right in between the two different base lengths. And so we'll average the bases and then multiply by the height to get the area of this trapezoid. And so, okay, an example problem, if this guy would click, come here, buddy. You can do it. There we go. So here, I've got this trapezoid. Notice that the larger base is on top. This is totally fine. There's no rules for where the bases have to be. They could be on the sides. As long as they're parallel, they're the bases. And so I've got two different bases, and I have a perpendicular height. So I have all the pieces I need to find the area of this trapezoid. I need to average my bases and times the height. So I'm going to take my two bases, base 1 and base 2. I'm going to add them up and divide by 2. And then I'll multiply by my height, which is this perpendicular height here, and that's 5. So remember, order of operations, you're going to do this parentheses part first. Add these up and divide by 2 and times by the 5, and you end up with 130 square inches. And you could also say 130 inches squared. So again, more than one way to write your units. Just remember, your formula is average your bases times your height to get the area of your trapezoid. Now we get to do things that are a little different. For your rhombus, okay, a rhombus is just a parallelogram. And so you could use area equals base times height. That totally works, unless you don't have your height. If you don't know this distance from top to bottom, you're not able to find the height. But the rhombuses use a trick. Since the diagonals are perpendicular, it does all sorts of magic with these triangles, and it turns out that to find the area of a rhombus, even if you don't know the height, you can just multiply the diagonals together and divide by 2. And that gives you the area. So you don't have to do any goofy Pythagorean Theorem stuff to find the height or do anything with all these little triangles. You can just multiply the two diagonals and divide by 2. And that's going to give you the area of your rhombus. So you go, okay, ta-da, here's a rhombus. And I'm going to say that, okay, this blue diagonal is going to be 8. And this red diagonal is going to be 12. And since I know it's a rhombus, because all my sides are congruent, I can go ahead and use this formula of multiplying the diagonals. So I'm going to take with the one diagonal that's 8, the other diagonal that's 12, multiply them together and divide by 2. Well, 8 times 12 is 96. Divided by 2 is going to give me 48 square whatevers. And so I'm going to put square units since I don't know what those whatevers are. And so it's kind of magical that even if you don't know your height, so that you don't know what these are perpendicular to each other, you can still find the area of a rhombus. Extra bonus, we have another quadrilateral that has perpendicular diagonals. It's a kite. And so for a kite, it's got the same formula because the magic of these perpendicular diagonals. So the area of a kite is also going to be multiply your diagonals and divide by 2. So they don't usually teach you this in elementary school and middle school, but now that you're in high school, you get to learn these magical new area formulas that are based on diagonals. And so you look at your kite and go, okay, if I just know these two diagonal pieces, I can multiply them and divide by 2. And so we go, okay, ta-da, here's a kite. How do I know it's a kite? Because these two pieces are not the same length as these two pieces. But I know that my diagonals are perpendicular. And so I'm going to go ahead and find the area by doing diagonal 1 times diagonal 2 and divide by 2. Now, oh dear, I'm going to have to do a little bit of work to figure out the length of my diagonals. My diagonal 1, this guy going across here, has got a piece that's 4 and a piece that's 9. So I'm going to have to add those together to find the length of that diagonal before I do any work with my area. So I add 4 meters plus 9 meters and get 13. Then for this other diagonal, it's 3 and 3 because the long diagonal always bisects the short one in a kite. So I had 3 and 3, and so that gave me a 6 meter diagonal here. These are the numbers I'm going to then use in my area formula and say, okay, I've got 13 for one diagonal, 6 for the other. Multiply them together, take half of that. Dividing by 2 is the same as taking half of it. And you're going to end up with 39 square meters. And you notice that I've written it another different way. I've abbreviated square and I've abbreviated meters. Totally fine. You could also do meters squared, whatever, as long as you don't leave your numbers naked, and when you're finding area, you always give me square units. Okay, so that's your lesson on the area of different quadrilaterals and triangles. Have a great day, and we'll see you next time.